Okay, I'd say let's go. Yeah, welcome to this Radio Data Archives Roundtable today. I'm here with a great panel of speakers who are going to be talking right after me. Maybe I can just briefly introduce them. They're James Dempsey from CSIRO. There is young Grange from Astron, Mark Kettenis from Jive, Mark Lacy from NRAO, and Christopher Scholar from Meerkat. Unfortunately, Christopher won't be able to join us on the live call, but I have a few slides from him, which I will share with you later today. Or later in the talk, actually. So yeah, to get you started, welcome everyone. Please feel free to join in the discussion. Raise your hand on Zoom, and I'm very happy to let all of you speak, or join us on the BOF channel in the Discord. It is. Yeah, as I said, just for the housekeeping, we'll start the program with a few ideas from our side. A few things we just want to highlight, a few things we think are cool about radio data archives and stuff. Then we'd be actually more than happy to hear about the status of your archives that either you're running or that you're using a lot, things that are currently going on that you would like to mention and highlight and would like to discuss. And then we're trying to take a look into the future to see what do we need, where do we want to go, and so on. And yeah, well, we're very happy to communicate whatever channel works best for you. Why this BOF today? So maybe I can just start by introducing myself a little bit. I'm a postdoc at the CDS, and I'm a average radio astronomer, I would say. I like to do data mining because I'm convinced out there in the archives there's lots and lots of amazing data. And yeah, especially my quest is give me all the H1 data cubes that are already observed, and I'm very excited about all the H1 data cubes that are going to be observed in the future. And yeah, but when you start doing these discussions, and at the CDS, I'm very happy, I'm very lucky to be exposed to lots of these discussions about archives and archives in the future, and being part of this ESCAPE project where European institutes are talking about these things. Yeah, we're trying to think about what do we want to do in the future, what kind of metadata we might need. And what I realized is maybe within the CDS we are discussing these things and everybody has great ideas, and then we open the discussion up to other people and there are more and more ideas. And this is why I thought we should have like this very big table and open up this discussion to many cool people who can come up with good ideas and yeah, really just find good solutions. So the plan of the BOF today is really to invite everyone to discussion. And yeah, while I'm here and got the mic, I might also like use it to promote the poster by Mireille Lewis, where we at the CDS were just thinking a bit about what kind of metadata we might need and how we get the metadata and how maybe a service might look like for visibilities in the future. So yeah, if you like, please have a look at that. Yeah, and that's my very brief discussion. So I'll stop sharing my screen and hand over to Mark Lacy to say a few words. So Mark, if you're perfect.
Unmute. Thanks, Katharina. That was a very nice introduction. So I'm going to start off by putting a little bit of an ad in for the VO. We've just started a new radio interest group at the IVOA for radio astronomy, basically to try and get some of these ideas that Katharina talked about, how to get radio data into archives and things like that. I also wanted to sort of remind people, I'm sure I'm preaching to the converted in many respects here, that you already know about the VO and like it, but I just wanted to give people a brief overview of what we can do here. If I can actually change my slides. There we go. So why would we use the VO? The VO provides a set of standards that allows the interoperation of archives via common metadata standards and protocols. And so if archives adhere to these standards, it means an astronomer can search archives in any wavelength domain using common interfaces or tools that use those interfaces under the hood. By including radio data products in the VO, it opens up the radio domain to astronomers whose specialties may lie in other wavebands. And for radio astronomers themselves, we can also use it to allow flexible and easy searches. VO protocols are not tied to any particular software or programming language, and they can be accessed from your laptop, a server at a data center, or from the cloud. So it's very flexible. And VO standards are the underpinning that allows astronomy data to satisfy the FAIR data principles: findability, accessibility, interoperability, and reuse. So there are lots of VO services, basically, that most people use some sort of catalog search, either a cone search or a table access protocol to access tables, which can be catalogs of sources or it can be catalogs of data. Simple image access protocol is the one that you can use to get images. These were the user supplied sky position and return links to the data. And version 2 of this protocol allows you to search data cubes as well. And then in addition, there are many tools that we use that are VO aware, as it were, and can be used to search the VO for data and communicate with other VO aware tools via the SAMP protocol. So examples include TopCat, DS9, and Aladdin. So you can have a source list in TopCat and an image up in DS9, hit the button, and TopCat will radiate those data, catalog data to the image, and you have little regions pop up on your DS9 image showing those sources. In Python, PyVO, now part of AstroPy, and AstroQuery can be used to access VO services. So let's just have an example use case here, which I came up with. So if you want to do H1 stacking with the SKA data or something like that, you can start off with an optical survey. I picked Dempsey here. That's a nice logo. But it can be any one of the large fiber surveys that are going to be conducted over the next decade or so. Get registers from that. Get cutouts from your SKA data archive using DataLink or SODA VO services. And then you've got your science paper without having to know anything about the details of the archives for which you're getting that information. And the nice thing about this is very scalable. You can do this for 10 objects, you can do it for 10 million objects. So as I said at the start, we have formed this radio interest group in the IVOA. It provides a platform for a discussion of how best to integrate radio data into the VO, including development of use cases. We're trying to identify any metadata concepts that we need for radio data that are not currently supported by the VO, and provide a well-defined point of contact for radio projects within the IVOA. And we also have a session at the IVOA Interop next week as well. So that's all I had to say. Thank you very much.
Thank you, Mark. And we keep on rushing through. If I may call Mark Kettenis for the next presentation.
You can, and I will show my slides. Oh, how do I do that? This is always, yes. So one of the things we are interested in knowing is what the kind of data is that various radio archives around the world are serving. And we are especially interested in what we might have missed so far. So the things we sort of have been thinking of as most archives offer some kind of raw data at this point, either single dish voltages in FITS format, interferometer visibilities in some data format, or beamform data from an interferometer. Many of us also provide some sort of pipeline data where some quality assurance on the data is done through diagnostic plots, some initial calibration is done, and maybe even some automatically generated images from the data are generated for spectral cubes. And some of that information is published in the regular archives. But some of that information is published in the regular archives, But we're clearly seeing a shift towards the desire to publish more science-ready data. This is on the one hand driven by multi-frequency and multi-messenger astronomy becoming more popular, which means that you have non-domain experts that are interested in the data, and having an image is much easier than having to get a collaboration going with somebody who knows to get from VLBI interferometer visibilities to an image. But another driver we are seeing is that in some cases, storing the raw data is simply not feasible, and only processed data can be offered. The prime example of this is the SKA, which will generate petabytes of data per day, or and there's no way to store all the visibilities. I also noticed that there's some data that typically doesn't get published. I don't want to call out specific communities, but for example, the NRAO archive has this disclaimer that certain data from the Pulsar backend on the Green Bank telescope is not in the archive. And I think there's in many observatories cases where data isn't published. Sometimes this is because the observing mode is somewhat non-standard, and therefore it doesn't fit very well into the archive structure. In other cases, it is because there's a special dedicated community that maybe even brings their own instrument and takes care of this all themselves. And then there's a third kind of data that you could think of is the actual science data. So what happens to the data after it's downloaded from the archive? For example, in VLBI, what people do with the visibility data is make an image, but the only place you can find that image is in papers. Often it isn't even available in digital form to people anymore. And one of the things that we could do is publish these derived products alongside the raw data that they were generated from. So that sort of points to where we maybe want to go with this. Should observatories maybe assist their users, the scientists, with publishing that data? You could think of a structure where NRAO would offer the ability to publish the images that were generated from VLA data. Then you see that a lot of instruments have these are starting to do these legacy surveys where a group of PIs get together, get quite a large number of hours on the instrument to do a survey, and then to some extent automatically process the data. What's the best place to publish this data? Should the observatories assist with that? Is it purely the responsibility of the individual team? Or should there be some sort of community managed long-term archive? This is what LOFAR basically does. They teamed up with some additional organizations to basically host an archive for them and manage it. Then there's the question, should we continue to provide raw data? I think we should continue to do that for as much as we can, because it allows you to go back and see if you can derive better ways to get more information out of that raw data than anything that was done by the automatic pipeline. But it's certainly not practical in all cases. Then several of us, especially in the ASKAP project, are working on integrating our archives with science analysis platforms. What does that mean for the data we offer? One thing that is clear is that connecting the science platforms with our archives will be much easier if we support VO protocols in our archives, which a lot of our archives still don't do. Especially when you're thinking about science-ready data, it becomes important, I think, to also record the provenance of the data. What happened to the data before you as a scientist got it? And then there's the question of providing the tools to the scientists to process the data. I think it would be good, and this is one thing we're going with the EVN archive at Jive, is to actually publish alongside the pipeline data, also publish the scripts that were used to generate those diagnostic data products. And the way we are thinking about this is doing this in the form of a Jupyter notebook, where people can take the notebook and make changes to the parameters that were used to process the data and get an easy head start on working with the data. Then the last slide is sort of a pet project of mine for ASKAP as well, in the sense that I'm trying to get media type standardized for certain data formats that we use. I try to do this for all fields of astronomy in ASKAP, but I try to get it started with radio. We're seeing that most of the data transfers are now done using HTTP transfers. It's very easy to associate a media type with such a transfer, such that the application on the other end can get a better understanding to what it should do with that data. But also many of the IVOA data discovery protocols use these. We have these already for FITs and UV FITs. The question is, can we standardize this for other types of radio data? I've listed here the types I think should at least get it, but maybe the community has some more suggestions. And it would also be interesting to know if somebody is already using a media type for one of these data formats. So that's it for me.
Okay, thank you, Mark. And next up, James might provide us some insight how the ASKAP is dealing with these questions of what to store and what not to store. So James, take it ahead, please. I can't hear you right now.
There we go. Is that any better?
Yeah.
Yep.
Wow.
Excellent. Okay. I thought I'd start by talking about some of the archives we run and what the sort of types of data we store. So starting with CASDA, which is the archive for ASKAP, and I guess these are in order of the newest to oldest. And ASKAP, the CASDA is very much focused on science-free data products, so images, image cubes, spectra, catalogs, but we also support story visibilities, and we also support having science teams load up their science products to the archive as well, so they can sit alongside the pipeline data. Next one is the Pulsar Archive, which is predominantly Pulsar time series from Parkes. And both of these two, we have a web interface through SARA's multidisciplinary data access portal, but we also support some virtual observatory protocols as well. So TAP for looking at for listing observations. In CASDA, we also provide affiliate protocols for querying and retrieving all the part of the data. And we've also recently put in an AstroQuery module for CASDA just to allow that programmatic access make it a bit easier. And the last one is the Australia Telescope Online Archive, which is largely focused around raw visibilities from the compact array, but other telescopes as well. And again, it has its own website and provides tap access to the observations. The question I wanted to sort of ask here is what should we archive? So the array data is big. I've listed on the side here a few of the drivers of size, and whether they're probably around signal dishes or interferometers, and we're probably all familiar with these. But this is sort of balanced against observatories or archives having limited storage and limiting archiving infrastructure, and it also contend that there's a limited capacity for astronomers to interact with a really large data. The large data is more awkward to work with, even if it is sort of more detailed and quite interesting. So I thought I'd take a couple of examples. First of all, ASKAP. So we start, for the beamform was looking 20 terabytes a second, terabits a second, correlators 10 gigabits a second. But even then, by the time we get through to the process data, the raw visibilities are still 120 terabytes a day, and the cubes, noting they also include some derived products, some supporting products rather than just the primary ones, is around 30 terabytes a day. Now, the decisions we've made on archiving is we just can't store the raw visibilities. That data scale is too large for our really for our budget. So we're currently storing calibrated visibilities only, but longer term, we won't store any spectral line visibilities. We'll only look at the averaged continuum visibilities. Now this has been controversial, particularly in early science, because if you spot a problem with the calibration and the raw visibilities have already been deleted, you can't go back and reprocess. And so sometimes it ends up being simpler to reobserve. And this is problematic as we're sort of pipelines require tuning for each science case and each project. To take a second example, we've got the cryopath coming up on Parkes as a cool phased array feed. Now, a typical pulsar survey might end up with 80 terabytes a day of output. Can this be archived? Probably, but for us, that's probably a bit too much for us. So a potential solution might be to use a buffer, process in real time, pick out the interesting parts and archive those. The problem there, though, is that what's not interesting today might be interesting tomorrow. And the classic example of that is fast radio bursts. That the particular data around the Lorimer bursts is probably regarded as not interesting at the time, particularly as I believe the telescope was pointed just slightly off the where it was supposed to be. So it might have been discarded, and thus we would have had to wait for longer to find these sort of discoveries. So that's sort of the question I want to throw out there is, what do we archive? Thanks.
Okay, great. Thank you, James. And next up, Jan would also like to share some insights from the Upper Tafe survey.
Yes, and I thought, I could tell you, give a bit of context on our archives and things. So, of course, Astron, we operate a bunch of instruments. Well, among which our largest archive is the LOFAR archive, which nowadays is order of magnitude 50 petabytes. There is mostly visibility data in there, so we do sort of offer visibilities to, well, whoever wants them. This is probably mostly because when we started doing stuff, the pipelines were not as mature as they are now. So I think our standpoint on the VO in that respect is if there is a good way to put stuff in the VO, that would be good, but we're not focusing on it right now. I think one of the things that we noticed, and I think that was already mentioned by some of the previous speakers as well, is that the sheer data size is making it very complex for bringing this data to like the end user. And also for us, because we store all our data on tape, so it already takes you a week before if you have a significant amount of data to download, it can take you a few days at least to get the data from tape to disk before you can even start downloading it. Well, of course, we're using measurement set there as well. So on the VO side, well, our first priority is actually looking at surveys, at old Westerbork survey data. So it's actually very appropriate that I have Westerbork on the background of my image. And indeed, nowadays we have, of course, Apertif, which is basically a refurbished Westerbork telescope. Let's call it like that. And it's quite a nice coincidence that today we actually I got the email already, so it's even formally public, that we are releasing the first data release from the Apertif system. We have put it in VO. I think an interesting thing is actually that we try to make it so that so you can find the table describing the visibilities data in the VO, but we still have a manual step again because the visibilities are on tape. But you know, if you take your favorite VO tool like Aladdin or so and you search for the Apertif survey, you can actually already download the images and have a look at it. So I think that is really cool. I also wanted to mention very shortly that timing data is something we are also very interested in, of course, because that's something that's important as well, and we should not forget about that. But it's not something that we have done a lot of effort right now in putting in our VO. That's certainly something that I think we should also have look at. And I think that's about it.
Okay, cool. Thank you, Jan. Then I'll share my screen again to show the slides that Christopher sent me. Here we go, I believe. You should now see Meerkat. If not, please shout at me. So here's just some basic information for the Meerkat Archive. The Meerkat Archive is split between two tiers of storage, the medium and the long-term storage. The medium-term archive provides low latency access to the data products. However, as space is limited to 6.5 petabytes, we need to argue that the data is aged out after 200 days and pushed it into the long-term tape storage. And the long-term tape storage is set to hold the data for about 2.5 years on 18 petabytes of tape. They plan on expanding this archive, and then they will be able to store all the visibilities indefinitely, provided the build out over the next 2 years is successful. One thing to note about the medium-term archive is that it's a Ceph object store. Ceph provides S3-like access. This opens up the possibility of providing direct access to the data using HTTPS calls from anywhere that has internet connection. And yeah, it just says in South Africa, they have 40 gigabit academic network. And the link to this network is currently 10 gigabits, which means that they could potentially transfer lots of data directly from the archive and directly to academic institutions. For this archive, they've also developed the Meerkat visibility format. It takes the advantage of the S3-like access to the data store. They break up the visibilities into 20 megabyte chunks of data, and each chunk contains all the baselines and a subset of general polarization and time. This allows to efficiently load and inspect polarization portions of the data over the network. They provide data access layer called catdel in the form of a Python library, and they also, so here's the link to that Python library. Oops, sorry, and I'll post that into the chat in a bit. If you're interested, please have a look at it. They have it on GitHub. There's read the docs, and it's available from PyPy. And this package allows for efficient data access using modern protocols and libraries. However, it is unfamiliar to most astronomers who work with measurement sets and CASA for the processing. So their idea is to marry the modern data access and cluster computing with the familiar and trusted code base that astronomers are used to for imaging. And that's a challenge for them, as people tend to use the familiar tools, like back at the bubbles talk we had, buff we had the other day. So for now, they do provide a way to convert data to the known measurement set format. But internally, they're using already CatDel for inspecting data, performing quality assurance, and so on. And they're looking into how to incorporate what they have developed in CatDel into more familiar formats. And yeah, I also bring up the email from Christopher, so you can contact him there if you like. So for now, I stop sharing maybe. This was the little introduction we prepared, and I can already see that lots of things are going on Discord, and we had a question before. So Malcolm just states on the Q&A, definitely observations and data centers should assist users publish their reduced products. Yes, which would be nice and would be easy for people like me. So yeah, we'd really like to open the floor now. If people raise their hand in Zoom, I'm happy to give them their mic if they want to talk or comment or question anything we were talking about just now. I'm also having a bit of a, maybe I can just share my other slides again. I'm trying to bring up a bit of the topics that we could be discussing. Just a second here. There we go. And yeah, in particular, I'd also like to invite people from other observatories that we maybe do not have on the panel here, but are dealing with similar thoughts, ideas. Oh, I see Felix. And yeah, there you go. You should be able to unmute now and talk if you like.
Is that working?
Yes, that is working.
Yeah. Okay, good. Yeah, so because you mentioned other observatories, I might chip in.
Yes.
So for Alma, so I'm the group leader of a group of scientists responsible for the Alma Science Archive. And I can say that, yeah, we have the chance that we can still store our raw data. It's only about 1 petabyte in data total, so it's relatively easy. We have a relatively large coverage of science products already, and we're serving all of it, so science products and the raw data through SCIA, OBSTAB, DataLink. However, the visibilities, we don't have really a service for the visibilities themselves. They're kind of more attached to the other products. You get them essentially as auxiliary data. We have put a really large amount of work, and Mark knows about this, into curating our metadata to make sure that the searches are most effective. Because, for example, our visibilities for observing reasons are split in very small chunks, relatively small chunks, and we combine the metadata of several of those where it makes sense, where it's necessary, actually. And we also relatively actively contribute to AstroQuery. So some of software development happens paid by Alma to make sure that AstroQuery is very well supporting Alma.
Okay, cool. Thank you, Felix.
Can I ask you a question, Felix?
Please, sure, go ahead.
So do you have a specific backend for AstroQuery, or is it all done through standardized VO protocols?
It's a very good question. So actually, AstroQuery was written by Adam Ginsberg and starting with Alma, and he kind of reverse engineered our system. But now we're transforming everything to using VO standards. So it was in the past kind of homegrown, and now everything is VO.
Okay, thank you. Maybe I can just move on to Andreas. You should be able to talk now. If you unmute yourself. Yes.
Yeah, is it working? Okay. Felix, just a question. So you're saying, well, visibilities, and actually the question is probably for everybody, visibilities are more like an attachment. Well, visibilities are definitely not data products. They are raw, hard to deal with, lots of things you have to know to actually do anything with them. But what would you think is required to make them more useful or even searchable beyond just an observation?
That's a very good question. So we have talked about this a long time, but we do not plan to make them searchable at all. We think that in the way the Alma data is stored, it's not very easy for people to actually find out what's in there because of this very strong splitting. So you don't, for example, know what the sensitivity will be of an observation that you get, or the total integration time. So it's very hard by looking at the metadata of the measurement sets alone what actually you will get. So that's why I think we will continue to make people search on the kind of combined metadata, and then if they find something that is interesting for them, then they will be able to download the corresponding raw data.
Mm.
Yeah.
I think that's about what people have in mind right now. Going into the measurement sets, that is just horrible, because it would be also different for every single observatory. So it's just really horrible to do anything on that level. But Mark,
So,
maybe you have some insights there as well.
Well, in our case, I just can say that, for example, for a mosaic, we had about 300,000 rows for, how many, so I guess, no, 3,000 rows for a single observation. If you would just take the metadata from the measurement set, and people were just overwhelmed with those.
Yeah, I guess this is something I realized as well when I was trying to do some kind of data mining, data archive search for, say, all the emission line observations. It's sometimes hard to estimate just from the standard metadata you can get what you have in the end, whether it's actual, whether the, say, yeah, how sensitive it's going to be and these kind of things. So, but yeah, also when the little project we had at the CDS where we're trying to figure out what kind of metadata do we need for visibilities to make them discoverable, it was hard to define this metadata in the first place, and then we don't have any information on sensitivities, because I think that's a lot of computing power you need there as well, especially when you first have to find all the data that belongs to one observation and then split it again and so on. Okay, so thanks for these insights. Any other things right now? I've seen that on Discord things are already popping up, and I wasn't able to follow them by reading. Jan, do you have interesting points coming up there? Sorry.
So I see one of the participants who is not on Zoom, because else I would have certainly pinged him to actually tell us that. Was telling that at the SOAR telescope, they're working on providing science-ready data, but raw data is already available. I would be very curious to hear actually, well, how it is available, like the questions that you ask. Oh, sorry, maybe Simon Torres could actually come to Zoom. Sorry. Let's see. Then there was some discussion on data. I call it the point that Mark was making, but I see that Mark was already in that discussion. So I'll keep an eye on what happens on Discord. That's about it for now.
Okay, cool. So, oh yeah, and François is pointing out that MWA in Australia is also starting to provide VO services for very low frequency data, which is cool.
That's done already. That's where I'm coming from.
Yes. Oh, Andreas, is that you? Oh, cool.
Yeah, exactly.
Do you want to tell a bit more about that?
I can, yeah. So quite some time ago already, we had a special project going on that was supported by the Australian Astronomy Limited to implement a VO compliant interface to the MWA data. that was a 1.5-year project, and ended up in having essentially a VO interface to it. Now, NWA data is only visibilities. There's not a lot more than that at all in there. There's actually quite a bit of voltages, even lower data, lower quality, not quality, but more raw data even. So that is actually a fair chunk of the whole data set, but altogether it's currently about 40 petabytes or something. So it's a very, very big data set of all kinds of observations, solar and lots of EOR data as well in there. So yeah, it's pretty expensive. Now, as I said, the access to that one is mostly through the observations. So you go through a tab service, which essentially queries the observation table, including the metadata for those observations, and then you can get access to the raw data. You can also launch a UWS service to get calibrated data out of that. You can have either both or just one of them, depending what you're selecting there. And that is quite useful. What came out of that as well is a additional Python implementation of re-useable, which is totally open source, so people can use that. Yeah, that was a pretty good exercise, I think.
Okay, cool. Thank you. So we see that lots of archives or observatories growing around the world with interesting archive features. I've seen that Harrison has raised his hand, so I'll give you the right to speak now if you want to say something.
Thanks, Katharina. Can you hear me properly?
Yes, I do. Sorry,
I should have piped up just before, but it's quite late here in Western Australia. I work as the lead developer for the NWA node of the All Sky Virtual Observatory that Andreas was talking about just before. So yeah, it's like you said. So the NWA is it captures there's a couple of different kinds of sort of options of observations that we're able to capture from NWA. One is just capturing sort of raw voltage data, and the other type is sort of calibrated visibilities, and then that's sent down via a fiber optic link to the Pulsar supercomputing center, which is about 800 kilometers away, to our 40 petabyte archive. So there's been some interesting challenges with that just recently, where we are nearing the sort of end of our archive with Pulsar. So we're almost filling up the 40 petabytes. So we've had to try and implement some policies to be able to manage that, because even though as much as we would like to be able to store all of the data indefinitely, unfortunately, that's just not feasible at the moment. So the sort of policy that we've been able to come up with is a sort of combination of a first in, first out queue. So we're going to sort of segregate some portion of the archive, say 30 petabytes or so, in that FIFO queue where older stuff starts getting deleted after a certain period of time. But then we're also providing a mechanism for other people within the collaboration to reserve data that they still need as part of their research. I might not be able to answer all of your questions regarding the data itself. I'm still relatively new in the role, and I am a web developer, not an astronomer by trade, but I'll do my best if you do have any questions.
Okay, beautiful. Thank you very much.
You're welcome.
So, yeah, so it sounds really good. So we got lots of data providers in the call. Are there any users by any chance, any power users who want to comment on any things at this point?
Well, I suppose I could comment from the user perspective. I was
please do.
Thinking about Andreas's comments about how do we make visibilities useful. So one thing that we are trying at NRAO, and sounds like they're doing it for MWA as well, is the idea of a science platform, so you can process the visibilities on the remote server. and reprocess them to make the images exactly the way you want, because us users can change by changing the visibility weighting and things like that. We can change the sort of image you get and tune it to our specific science needs. So that's the way we're trying to go, is to do a platform essentially that allows people that initially it'll be very simple menu-driven processing. It won't give you many options, but we're going to develop more options later. And I personally find that very useful, particularly the calibration side of it, where we can deliver calibrated visibilities. Takes a lot of the pain out of going through CASA line by line with your bad CASA script. And it really helps to have a pipeline that will give you reliable calibrated data, which you can then image either on the server or on your own machine.
Mark, can I ask you a question as well? Follow up. What do you think about providing good quality measures for people before they actually even try to get to the data? Even if it's calibrated, you don't have an idea whether it's good or not.
Yeah, I mean, so we're doing at NRAO is a pretty simple, is it good? Does it pass our standards or not? Type quality measure. But we also include comments on what we had to do to calibrate the data and get it right. So I think it doesn't probably need to be too complicated. Just, is this data good or is it not good? Did it calibrate well? That satisfied our what we call our science ready standards, which is is it good such that a reasonable observer would be happy with it? Does it satisfy a consistent set of standards that we set up for being usable? Yeah, so I think, yes, having quality there is very important, but it doesn't, I don't think it needs to be too complicated.
What about RFI?
Yeah, that's interesting. So for continuum, yeah, we certainly try and excise the RFI, but if there's a lot of RFI, the low level stuff, if you're making a continuum image, it doesn't matter too much because the visibility weights get set low, so the data is noisy, so it doesn't actually contribute much. Where you might have to do more careful flagging, and I think this is going to be something that we're going to face in the future more as we go into spectroscopic modes, is that, of course, as soon as you start splitting up the data, a little bit of RFI can affect you a lot more in frequency when you split the data in frequency. So that's something I think we have to worry about. But for the moment, yeah, if you provided you excise the gross stuff, the little bit of low-level RFI is not too bad for continuum imaging.
Okay, I think Felix might want to comment on that.
Just a very quick point on that. So I can say that in Alma, we try to do quality control automatically through the pipeline. And there's a number of scores for quality. And also people are looking into machine learning to define the quality. But I think it's fair to say that it's a relatively difficult and hard problem to solve.
Yeah, I think the general problem is really hard, right? Yeah, because you don't know necessarily what the science use case is going to be. And if it's doing a very sensitive observation of a very narrow frequency range, you might have RFI or other contaminating issues, then that becomes a much harder problem.
I was just going to point that in ASKAP, the approach has been to have the science teams produce validation suites, and so they produce the tests, and they validate that the data products are, or the observations and the derived data products are suitable for their science, and then we can publish them on the archive so they're accessible to anyone who wants to use them.
And Mark, Kettenis, you also have your hand raised. Did you want to?
Yes, two things I'd like to say is that some experience we have in the Event Horizon telescope is where, which is VLBI, which is even harder to deal with the visibilities than any of the other instruments. But what was done there is that all the hard calibration tasks were done, and a set of calibrated visibilities was delivered to the imaging team, and the imaging teams are teams, and the imaging teams are not necessarily VLBI experts or even not even radio astronomers. And it is interesting to see what they were able to do with those calibrated visibilities in terms of new imaging techniques, but also modeling of modeling efforts, where you try to model something and match to the visibilities instead of the images. So I think there's certainly value in providing data sets of calibrated visibilities where you need some expertise about radio imaging, but maybe not so much specific instrument knowledge. The other thing I wanted to point out is that Mattia, and I have to look up his name, and he scrolled around from Astron. Jan, help me.
Yeah, Mancini.
Mancini, yes.
Mentioned as one of the heroes who has been doing a lot of work on the operative.
Yeah, so we're actually looking into getting some decent parameters to characterize, for example, UV coverage, which is one of the potential quality measures, such that you can actually query on them using VR protocols and say, okay, well, don't bother about returning any data that has poor UV coverage.
Okay.
It would be interesting to indeed have a characterization parameter for RF, for example.
Yeah, that would have been one of my questions. Can we find quality things that we can put in a VO table and then be like, oh, I only want to have the very nice images. But let's see, I think Jan wanted to say something, and after that I have Francois raising his hand. So Jan, go ahead.
Yeah, well, since I took it on me to sometimes echo things I see happening in the Discord, there was some comments on the basically the possibility of investigators to upload processed images back into the archive. I think that was already mentioned. I think that's certainly also a topic that I mean, it already got 3 likes, so I just wanted to mention that's something that's certainly a living point to make, and I mean, it's something that, I mean, we're doing at least with the large scale surveys, but not for the smaller scale users. And of course, you have to put a limit somewhere. At some point, you probably say that's the role of CDS, but.
Yeah, I mean, at the CDS, sorry, Francois, I'm going to ask you to talk straight away. At the CDS, we do have the option to upload small data sets. And I uploaded some H1 data cubes from a small survey I did 2 years ago. I have actually no idea whether anybody knows they can find the data there. I might have mentioned it in the paper. And I don't know how many people downloaded it from there, so I should check this at some point. But yeah, there are options. Like these are standard H1 data cubes from the ATCA, so they're not ginormous 1 degree things with terabytes, but things that you can handle. So yeah, these options don't certainly exist in the CA associate data thing. So, but yeah, now I ask Francois to talk.
Yeah, no, just to answer Mark Kettenis' point about Mattia Mancini work. I think maybe it will be good to write in the. I can do it actually to give a link to the ASKAP discussion we had in the last months about this work. So if nobody against, I can point people to these pages on the ASKAP site?
Yeah, please do.
Matthias is totally happy with it.
Dana, you're muted.
Okay, that's fair enough. Well, but now I'm not good. Yeah, I just moved on my slides because we're already starting to go a bit into this direction of creatively looking at visibility data that might be in archives, but also like the science platforms and archive properties we might want to have in the future. So in the sense of available data formats and file formats, I think we're still mostly working on measurement sets, right? I was interested to see that Christopher at Meerkat is having this new format. Is there anyone around who can talk a bit more about that? Moment. No, probably nobody's heard of it.
Oh, that, no, yes, I have something to say about that, but maybe continue.
No, it just sounded like an interesting thing. So yeah, I was just wondering if somebody has more to comment. So please go ahead, Mark.
Well, I think especially when going to science analysis platforms, rethinking how you store your data is certainly a good thing. Traditionally, data has been stored in files, but a lot of these cloud-like infrastructures don't really have the concept of files. Within ASKAP, there's a whole work package about creating a data lake where you throw in all the data that you have, and at some way you find it back in an efficient way and can run code on it. I'm not very much involved in that, but it certainly isn't simple files. It's also, if you want to efficiently process data, you actually don't want it all on a single hard drive. You actually want to have it spread around on multiple storage facilities and CPUs, such that you can read it in parallel and process it in parallel. And the measurement set certainly has problems there. You see that people are slowly developing these more modern cloud-like analysis software bits like Dusk to use that data. And sorry, now I've lost my train of thought. Within CASA, NRAO is thinking about the next generation of their data reduction software. There's an NG-CASA sort of pilot project that is looking at exactly this, to find a more efficient way to deal with the data. And maybe thinking about data in terms of file formats is not the right approach, and we should more think about data models. As long as the data model is the same, it doesn't really matter that much how the data is stored on disk. In fact, in CASA, in the measurement set, there's this concept of storage managers, and each storage manager has its own file format. One example of something that happened at Astron is that somebody developed a nice compression algorithm for LOFAR data and implemented that as a storage. This format is called Disco, and implemented it as a storage manager for CASA. And if you have or for CASA core, and if you have the right plugin module, you can just approach data in this format as a normal measurement set. The same was done for HDF5, I believe, that you could use HDF5 as the backend of certain columns in the measurement set. And it would be stored as HDF5 data instead of the native CASA core format.
Okay, cool, thank you. François, I've seen that you have still raised your hand. Did you want to say anything else? Otherwise, I'll just call on Andreas to comment.
Yeah, Mark, good points there. I can just add on top of that. So we've just started writing a storage manager, which actually connects the two worlds in a way. So we are trying to put the storage manager in place, which can actually write to Plasma in memory, and then use the very modern stuff like Parquet and all that kind of stuff in the background, whatever you want to do off that stack, but still has the same access model of CASA core. So I think that is actually a really interesting way of doing it. It's a bit similar to what the NG CASA is also doing. I think we can't really go around that because there's so much data and measurement sets still. We have to somehow support it, and just converting it, I think, is not a good solution for that, because especially with the sizes of data we have, conversion is a pretty big overhead. So I think going for something like storage managers is actually a really interesting approach. The other thing, and I agree there with you as well, again, thinking about splitting the data model of the measurement set from the format, which is currently just mixed together, is exactly what we started doing in the SKA as well. So I've actually put together a clean data model for a measurement set, which doesn't impose any formatting. And hopefully we can push that forward and have the model still maintained, because that won't change in reality, and then can use that model across all these new technologies or whatever people want to do underneath. That goes a bit hand in hand on what had been done in Alma as well with the ASTM, although that again was linked to an XML format, which was a bit strange, although it was called ASTM. There was also an ASDF at some point, but the whole thing was mixed together again, and that's unfortunate. But in principle, the model itself is valid across many instruments. And from that point of view, actually the ASTM data model is probably the most complete at this point in time in terms of supporting radio data in general.
Okay, thank you, Andreas. Okay, any more comments at the moment on these topics? I do see a few raised hands. So Mark Kettenis, please go ahead.
Well, at some point you should stop giving me the microphone. An interesting thing there is what's important is if you actually want to be interoperable, the sort of common data formats better data models is sort of important, because it really the strength of the measurement set is that I can use CASA, but also Oleg Smirnov's matrice and some tools that have been developed for LOFAR on data sets from different observatories. And an interesting thing that we had in the Event Horizon telescope is that we considered using the measurement set there, but because there were too many tools that people wanted to use that didn't take the measurement set as input data, we had to fall back on good old UV fits to do things there. Now the data sets are small, so there's not that much of a downside on it. But yeah, we have to be careful that we can come up with these really clever new formats, but if there's not enough tools that actually speak that format or data model, then we don't really win anything.
Okay. I also have a comment on that from Paul Barrett in the Q&A. He says, in my opinion, the data format should never determine the software design. Once you do that, you lose control of your software. So yeah, so I guess it's a difficult question, the data format one. Yeah, Paul, if you want to comment more on this, please raise your hand and I'd be happy to give you the mic too. Yep, there we go. Do go ahead, Paul.
Can you hear me?
Yes.
Yeah, okay, good. Yeah, no, I've seen this in other software development projects where the software is primarily designed around the format, and once the format becomes old and antiquated, you're pretty much left with old and antiquated software. And it typically has what I find a huge impact on high performance computing in terms of scientific computing. It tends to be the limiting factor in the performance of the software. You know, the software should be able to handle any type of incoming data format. I know that sounds a little easier than it is at times, but that's just my opinion on how things should be done based on 40 years of software scientific programming.
Okay, thanks, Paul. People who are actually developing software around radio data formats, which I personally don't.
Well, yes, I as a counterpoint is, of course, efficiency is not purely about computational efficiency. If people don't have the tools to work on it because only a specific tool has that data format, then it doesn't work. So you can tolerate a little bit of inefficiency if it means that people get the job done.
Well, in some sense, I mean, I go back to having worked in global navigation systems. They've chosen to have all their data as an ASCII file, and they read and write the ASCII file. And as a result, their software is 100 times slower than it could be. It takes maybe an hour or more to process Earth orientation positions, and it could probably take less than 5 minutes if they wrote their software properly. I kind of see this with CASA. I think CASA probably could be sped up by a factor of 3 if they implemented their software better and got away from reading and writing files. I've been writing software myself for CASA, and I get much better performance out of it. So file I/O tends to be the limiting factor in a lot of software nowadays.
I think if I can chip in, I think that I'd like to make a distinction between the specification of the format and then the implementation of the format. So I think in radio astronomy, for example, we have the measurement set version 2 specification, which actually I'm quite grateful for, because I think it's kind of the lingua franca. It allows us all it allows all our software to communicate with one another. Now, obviously, the Casa table system is the implementation of that, but I don't think we should necessarily throw the specification out with the format. And I think it's probably quite, well, it seems quite possible to me to apply the specification to new storage formats. Like, especially I'm interested in the Apache Arrow ecosystem and the Parquet file format. I strongly feel that there's an ability to get a one-to-one mapping between like a Casa table and a Parquet file. So yeah, I just wanted to throw my 2 cents in there around that.
And I think Thomas had a comment as well, and after that, Dirk.
Yeah, being a software developer myself, I got to support the notion that software shouldn't be designed around a data format, right? That's just plain wrong. Sorry. I mean, find your use case and then define a specification for your data format, and that's it, right? If archival of data needs a special specification, then have there a data format that is perfectly tailored for that use case. If you need to work on data, find a specification for that. So when you pull the data out of the archive, convert it into the working format, and then work on that. By that, you avoid inefficiencies on all fronts.
Yeah, I completely agree.
Yeah, I just wanted to, as a Casa developer, I wanted to come back to what somebody said earlier. The storage managers in Casa, no? I mean, in this, from that point of view, Casa is really a model of an implementation, because we could in principle, you know, switch to a completely different storage format relatively easily by exchanging the storage managers, and everything on top of it would stay the same. So it's, from that point of view, a very good implementation. Casa is not bad, but quite the opposite, I would say. It's of course a lot of work to develop these new storage managers, but we have already demonstrated that it works. There are all kinds of flavors of storage managers that Ger van Diepen has developed mostly, and at the moment we are just leaving them alone because there are more urgent problems that about let's say user interface and scientific correctness and so on, but I'm sure this could be revisited, and the storage manager concept is really the way to go. No, I mean you can
Dirk,
take a model and then underneath you can switch to whatever format you like.
Yeah, but Dirk, this is design. This is not implementation. It has nothing to do with implementation. It's a choice of a design. It's an architecture, right? If I decide that my way of storing things can be performed by a plugin, right? It's a choice. It's an implementation and design choice. And
sure.
How I implement the thing, right?
What I'm trying to say is that it's a very good choice, because it leaves, I mean, it keeps you or protects you from having to recode your entire software just because you want to replace the storage format. So
yeah, but that's a software design pattern for like 40 years now. I mean, that you modularize your software, right? That's nothing new.
Yeah, exactly. And Casa is nothing new. It's 20 years old, sure.
Yeah, so yeah, but the thing is that if I use the same data format for archival, I impose and the identical data format for working on the data, then I artificially impose inefficiencies on
exactly
on
what
the
we are not
task.
doing. In this case, that's exactly what Alma does not do. We have a separate archival and a working data format. The archival one is the ASDM, and the working data format is Casa tables implementing the measurement set. So we are not forcing that at all.
I think Andreas wanted to comment on that too.
Yeah,
Or did you have?
So I have to very strongly agree with you. That is just perfect. And Thomas, this is exactly the kind of thing which was actually mentioned before. So you can have whatever kind of format in the background. And you could, for instance, read directly from an archive if you like, but you can also read directly from memory because you can do these storage managers and have a totally different format in the background. And they even a completely different storage model in the background. Whether that's efficient to do that for a certain application, that's a totally different story. But you can make it efficient if you choose the right storage manager on top of it. So from that point of view, Casa Core is, and I'm saying Casa Core here, right, is done very, very well. And I don't think there's a lot we could do better than that. There are a few things which are still not working as they should. There's, for instance, a complete table locking in the system still, but that's details in the implementation, and we can definitely remove that. So in principle, the Casa Core system has everything we need to be able to be flexible even to the most modern formats. And that's what we've shown. We have an ADOS2 storage manager, we have an AG5 storage manager, we have a plasma storage manager, and that's all working. The plasma one is not complete yet, but that's looks very promising. Yeah, I mean, that's what we have. And we shouldn't throw that away because, as mentioned before, there's lots of software on top of that, which we can't all re-implement just because we feel like it. So I think the obvious way to go is to support that really nice way of doing it, and that's as modern as it can be. Into the future, we could even change the model underneath and say, well, we'll use a different model, which I don't think is really necessary at this point in time. Again, the model is very mature, especially if you look into ASTM. It's a very, very mature data model if you remove it from the format again. But doable, not a problem. I don't see a big issue there. So yeah, again, inventing something new just because we are not totally happy with one layer of the software, I think is not the way to go. If we can bridge the gaps, which is actually possible, then I think we are on a good track to go in the future as well.
Can I ask you a question? I think my understanding is that the Casa table system, and like as it stands, isn't thread safe. Is that incorrect? And if it's not incorrect, can that be rectified?
Yeah, so good question. So there are a few points where it's not thread safe, and but it can be made thread safe. So as I said, there are a few. First of all, it's 20 years old, so at that point in time, there was not even a requirement to run on multiple cores on a single system. So
sure,
you can actually imagine that there are some things in there which are not quite up to the standard. But the software is written very well on that level, and it's doable. So that's why there are a few locks in there which are not quite where they should be, and they are preventing scalability quite a bit. But yeah, I think it's doable, and it's definitely less work than re-implementing the whole thing.
Okay, nice. So maybe I chip in here. Before, so we don't have too much time left. So there was one thing that Mark Lacy brought up at some point, whether there's use for something like a radio data provider workshop. Mark, did you want to say anything about that?
So yeah, this cropped up in the context of the IVOA, whether it would be radio interest group, whether it would be worth getting data providers together. I mean, specifically for setting up VO services, but it could also have a broader role as well. Obviously, right now with the COVID and so on, we're probably looking at a year or two before we'll do that. But just wanted to see how much interest there might be in that.
So folks, you have 8 minutes left.
Okay, yeah, so we're in the, well, in the move of wrapping up, I guess. If you're interested in this data provider workshop, maybe you can just add your comments to our beautiful BOF Discord place. Sorry, I'm lacking words at the moment. And speaking of Discord, I didn't really see what was happening there. Were there any other things we should have highlighted or should highlight? Or any special discussions we didn't notice here? Jan, did you see anything?
Not something really special that I really saw. There was some discussion about the data models and well, all the stuff actually. But there was a bit in parallel to what was happening here, but not much extremely new, I would say.
Okay, then maybe all of my wonderful co-panelists, is there anything you came here to say today that you didn't get to say yet? Then this would be a good time. Yeah, so James, Mark, please just shout it out. Otherwise, yeah, maybe from the audience, is there any short final statement somebody would like to do? Right now I lost my window of audience again. Okay, so I guess we can conclude from this BOF that lots of things are going on, lots of developments are going on around the world, and I was very excited to see all the new developments today. This is partly why I invited such a great and diverse panel to see all the cool things you guys are doing. There is still some discussion, I guess, over data formats and well, implementation things. And yeah, but at least for me as a user, I also feel like I'm getting more and more access to more and more things. I'm still curious to see how these science platforms are going to pan out. At the moment, I'm not even 100% sure how, well, they might be very similar to the optical astronomy science data platforms, I guess, if we start serving mostly reduced data. But yeah, I see Mark has another comment on that. So please go ahead, Mark.
So not specifically on science platforms, but it is something we might want to discuss, and that is backwards compatibility. So already, as Felix knows, with Alma, we are facing a situation where we can't reduce some of the, we can't reprocess some of the early data with the early CASA scripts. Of course, the raw, starting with the raw data is fine, but we can't reproduce what we did without having to go back to virtual machines with an old version of operating system and CASA on them. So there are these sort of provenance issues related to the data, the stability of the CASA data model, the measurement set model as well, that we perhaps want to discuss. Or if anybody has any thoughts on that, it'd be interesting. I guess I scared everybody there.
No, I just agree with you, Mark, as you know.
At ESO, we have solved, at least temporarily, the problem by having a legacy machine actually that runs Red Hat 5.
Yeah, that's what we're doing.
A long-term solution, but I know from my short time at NASA that also big places like NASA are keeping legacy machines around in the long term in their archive to be able to access really old data. I mean, like decades old. So.
And I see Kana is having
a
a
matter of how much funding you have, I guess.
Sorry, Dick. Kana is also having a comment on that. Please go ahead.
Right. About the old data, old Alma data, how to reproduce the past processing result. Each Alma partners are approaching it slightly differently. And in East Asia, where we have created a system using Docker container, keep on operating old operating system on Docker container to create a service to reprocess reproduce the past processing result. And actually in this ADAS conference, Yohei Hayashi is presenting a poster regarding that system. So if you're interested in how we did it in NOJ, you could also visit the poster.
Great, thanks. If you like, you can also post the link to the poster maybe in the BOF so that people find it more easily. And yeah, I think we only have 2 minutes left. Before we start anything new, I would like to thank you all for your active participation. It was really interesting, all the things we heard. And yeah, keep on talking in the BOF, in the Discord. I'm gonna read it, and yeah, I hope to see you soon on some Skype call or something regarding this paper. So yeah, thank you all very much.